Today we are going to talk about the most popular weight loss injections and how they work in our bodies. Hello everyone. Welcome to our channel, The Streetwise Chemist.
Hi there, I'm the Streetwise Chemist, and this is going to be the first video, so bear with me. Come on, and I've got here Jam.
Hi, my name's Jamie Ann. So I've worked alongside the Streetwise Chemist since 2016.
The old man.
Yeah, since leaving school.
Yes.
I also trained as a nurse, and here I am today.
Yeah. So we're here, and we're hoping that we will give streetwise answers to otherwise serious questions that people have.
Yeah, so I thought we'd cover a trending topic at the minute.
Yeah.
I want to speak about weight loss injections. What's your thoughts?
That's okay. Let's do it.
Yeah?
Yeah.
So I want to know, what is the magic behind them?
They're magical. This
Yeah.
is what they are. They are very good. I don't think we've seen anything like this in terms of weight loss ever before. You know, there's been Olestat, messy Olestat. You know, people taking the capsules and then, you know, it wasn't very pleasant. If you've used Olestat, you know what I'm talking about.
If you know, you know.
If you know, you know. We don't want any messy business around here. And then, you know, those were the drugs. Of course, there are some people who've used the very bad science, and I'm afraid I know in some parts of the world people are still using these. They're using sympathomimetics, you know, like ephedrine, pseudoephedrine.
Oh,
You know,
okay.
like to say we're speeding up your metabolism, and then you lose that way. And then they use like laxatives as well, in combination with these adrenaline like drugs. But really it's a poor way of doing it, and if anyone is still doing that out there in the world, just not good for you. It's not good for your heart, it's not good for your blood pressure, because these sympathomimetics can constrict your blood vessels, speed up the heart rate, just not good for you.
Yeah.
So there comes these incretins. By the way, these the Mounjaros, Ozempic, Wegovy, these hormones were first discovered like around 1970.
Okay.
Yeah.
They've been about for a while.
But they've been around, but it was a way of then changing them into usable clinical drugs. That has been difficult, and now, you know, until sort of 1987, they managed to see how they can do that. So since the 90s and now the 20s, we've really got there. They're confident now of what they're doing.
Okay.
So it's a big question that you've asked, but you know, I'll try to
I'll try to
answer
break it
it.
down then. So
Yes.
how do they work?
Right. I think the best way to understand these, we call them incretins. I think that's an easier streetwise word to use. Let's call them incretins. It's an easier one. Yeah, they're incretin hormones. So the best way to understand this is to understand insulin. Okay, insulin is produced from your pancreas.
Yeah.
After you've eaten something, so there are messages that are sent to the pancreas. In fact, these messages come from the small intestines, at the end of the small intestine and the big intestines. So they produce the incretins. The incretins tell pancreas to produce insulin. And why do we need insulin? Insulin is the one that allows us to take glucose from the bloodstream into the muscles. Okay. So for instance, somebody who's got diabetes type 1, where they've lost the function of their pancreas, so they're not producing any insulin. They've got sugar going around in the bloodstream, but because they don't have insulin to allow that sugar to go into the muscles, they can go into what they call diabetes ketoacidosis, because the sugars are there, but they're just there, they're not being broken down, they're not being used up, and of course they pass through the urine, and they damage the kidneys that way, and when they pass through the urine, they draw with them some water. So the first thing that they notice when they have the pancreas is gone, you know, bust, they will be, yes, kaput, whatever you call it. Yeah, they'll be peeing a lot, so they're going to the toilet a lot in large volumes because the sugar, by osmosis, is drawing water with it, and then you're going to the toilet all the time. You don't have the energy because the muscles can't absorb
So that's one of the first
glucose.
signs, isn't
Yeah,
it?
so those are the first signs. So that's what insulin does. And of course, in type 2 diabetes, what we've had is people eating handsomely. Okay, so they're eating loads. So the incretins is low. They produce many incretins. They're telling the pancreas produce insulin. So the muscles are washed with insulin all the time. And what tends to happen then is you have resistance to the insulin. They're tired of this insulin wash all the time. We're eating a bit more than what we should do, and the muscles are thinking, come on, this is enough. So you're not absorbing the insulin, although it's there. So usually in type 2 diabetes, you actually have your own baseline insulin. Might be less because of other factors, which I can explain later. But generally, it's insulin resistance. This is why we give things like metformin, and metformin reduces the insulin resistance. So it allows your insulin to do the job that it should do. The primary job is to allow the sugars to be absorbed into the muscles where we need that energy. Okay, so that's a good way of going into the incretins, to say you need to understand the role of insulin, and that these incretins actually trigger the release of insulin.
So it's something our body naturally does.
Yes. So it's naturally what the body does, and these incretins as well, naturally, this is the thing, this is the point which they didn't get initially, that naturally the incretins only have like what we call a half-life of 5 minutes. So their total life from being released and being inactivated by our enzymes will be like 10 minutes, 12 minutes.
Okay.
Yeah. So what role they play to release the insulin, what role they play to tell the brain that I'm satisfied, or to reduce appetite, and to do other things that I'll come to later, which incretins do, there's not much time. So they're very short-lived. So the trick was then, how do we copy this natural hormone, which does so much good, but in a very short space of time? So, as you know, most drugs work as a keyhole and key sort of, So they found that, this is the key. And this is very clever, because the GIP, which was the first incretin that they discovered, they found the sequence of the amino acids. So it's a protein, what we call polypeptides. So it's like a protein. So it will have all these amino acids attached to them. Yeah. And then, of course, at the end of it, it forms a shape which forms the key that goes onto all these receptors in the brain, receptors in the blood vessels, receptors on the liver, in the adipose tissue, which is the fat tissue, receptors in the pancreas, and everywhere else which we know, even the back of the retina, believe it or not. So that's how they're going to act there. So they've discovered the key, and then say the next thing is to say, how can we make this last for longer than the 10 minutes that it naturally does? So they see that we have some DPP4 enzymes. So these are enzymes that, of course, in fact, you can just remember them as the DD-Puffy enzymes. We don't want to get in trouble here. But yes, but it's a way of remembering them. They're the DPP4 enzymes. So the DPP4 enzymes, they're the ones that inactivate these incretins. So they've discovered those. This is what inactivates the incretins. On that sequence that I've told you about of the amino acids, they know exactly where it does. So, so the position, whatever, 18, this is where it latches on, to break it down. So it inactivates the incretins. So what do? They then manufacture exactly the same sequence, well, not exactly the same, but similar sequence for most of it. And then they put on there an amino acid, which the enzymes cannot recognize. So now what you've essentially done, you've put dirty, whatever, resistant incretins. Yes. So now it's resistant. So now it's resistant to the incretin, to the DPP4 enzymes. So you cannot break it down. it lasts for longer until other enzymes that we have in the body that break down other proteins, because I said it's a protein, this one, break it down. So this makes it longer. So the half-life of these new ones, like tirzepatide, which is Mounjaro, the half-life of it is about like 5 days.
Okay.
Yeah.
So in comparison to 12 minutes,
To 12 minutes.
we're going to 5 days.
Yes. In fact, 5 days is the half-life, which means the full life is about maybe 12 days.
Right,
You
okay.
still have it in your body.
Yeah.
Yeah. So imagine 12 minutes to 12 days. It's a massive difference.
Yes.
And this is the magic of this thing. So in those days, it's telling your body you're satisfied, and it's lowering your appetite. Yeah. That's the function in the brain. And then in the stomach, in the belly, the pouch, which is what we call the stomach, the pouch with acid, things usually stay there for an hour. But when you're using these incretins, things stay there for longer than an hour, 2 hours, 3 hours.
You'll feel fuller.
You feel fuller. You feel fuller earlier because they're sending signals to say we've got food here, it's enough. When really it's not enough. Yes. So if you're taking less food, it's staying in the stomach for longer. What's in the stomach? Acid. Yeah, there's lots of acid there. This is why even if you ate a fish bone, by the time it goes to the small intestines, it's all softened up. Yeah, because the acid does the first major breakdown of the foods. Yeah. So in this case, we're staying for longer than we should, which means we're degrading the nutrients as well. Yeah. Usually you get your nutrients, they go into the small intestines, they get starting to get absorbed, but now, because they're staying for longer in the pouch with acid, it means then we're degrading some of the nutrients as well. So by the time they come out in the small intestine, then there is less nutrients to absorb. Okay. Yeah. So there are several ways in which these new incretins actually make you lose weight. Yes. Not only that, so we're saying when the food is then released from the stomach, because we slow down the gastric emptying, it means instead of the sugars going boom into the bloodstream, they're going as a slow release. Yeah. Yeah. They're going slowly in. So again, we actually know in some rats, they've seen that it can actually reverse. Remember what I've said in type 2 diabetes? There is insulin resistance. We think long term, the use of these can actually reverse the insulin resistance. It's something quite interesting as well, is we know that in people who are obese and those with type 2 diabetes, they've got more of these PDD enzymes. Okay. Yeah. So it means you're already big, you already have diabetes, but whatever incretins you produce naturally, they are broken down even quicker. Because, yes, so we find that the levels of incretins after they've eaten, when you're big or type 2 diabetes, are less than that of a normal person. Why? Because they've got the PDD stuff ready to even more than what we naturally have. Okay. Yeah. So generally, the incretins are magical. And one thing which I like about that is, listen to this, the glucose-dependent insulin secretion. That's what they trigger. Right. Yeah. Glucose-dependent insulin secretion. So it depends on how much you've eaten. So if you haven't eaten too much, then the release of the insulin that it tells you is only to that level. If you've eaten loads, then of course the message is to say, right, produce more incretins to that. So it's glucose dependent. So if someone was, for me, I know a little bit of background, if someone was type 1 diabetic, then they might be more prone to what we call hypos, which is low blood sugar. Yes, if they're using insulin. Yes. More. So one question that I would have is, do these put you at risk of hypos, low blood sugar? Good. It's a good question. This is why I think they're magic. Because they don't. How? Yes. How does it do it? Because it's glucose-dependent insulin secretion. Right. So if the glucose is normal, it's not going to tell the pancreas to produce insulin. Okay. Yeah. So even if you overdose yourself, on
Don't do it.
incretins. Yeah, of course. Yeah. If you overdose yourself on insulin, all the sugar goes into the muscles.
Mm-hmm.
There's no sugar in the bloodstream. The brain only functions with that, that's the energy that it needs the glucose. So the brain doesn't have it, you collapse. If someone doesn't serve you, we don't have glucagon injection, we don't have any sweets to give you, then you collapse and die. But with these ones here, it's going to be hard unless you're on other drugs like sulfonylureas, like glibenclamide, whatever, gliclazide. If you're not on any other drugs, you overdose on that. I can tell you, you'll feel horrible, you'll vomit, you throw up, whatever. You feel like you don't want to be here, but you're not going to collapse and die because it's glucose-dependent insulin secretion. You're not going to produce any more insulin than you need. So it's magic.
Yeah.
So I like it. I like it. And people say, again, I've told you about the sequence of them. In fact, one interesting fact as well is humans, pigs, all the other mammals, we actually, the structure of the incretins is almost the same. It only differs by 1 or 2 amino acids. Let's say against a cow or a pig. We're all the same, So it's very interesting that they're almost the same thing, and we find them in humans as well. So they're magical in terms of losing weight. I've told you as well about. I think I've told you about the receptors in the liver. So what happens in the liver? It stops the production of glucose. So we normally produce glucose, it stops that. In the adipose tissues as well, it encourages actually more production of glucose than production of accumulation of fat. Yes, so generally there's so many ways. So if it didn't, you thought, it's not suppressing my appetite. But don't worry about it. There are many other ways in which it's reducing your weight. Yes, and of course, different people lose differently, but I'm not going there until you ask me a question. Sorry, I can't stop. Stop me if I'm going over. Was that enough? Did I answer the question actually?
You did.
Oh, okay.
Thank you for watching our videos. For more videos, please subscribe and like our channel, The Streetwise Chemist.